Obscurea Thermostructural Sulfur Waste Upcycling Solutions. It is often said that the greatest triumph of modern man, and which ultimately gave elemental birth to modern civilization, is our mastery of the creation of heat in the form of fire. An elemental mastery, the opposite of which is naturally cold, of which our relative mastery has also positively impacted in numerous ways our modern way of life, certainly in ways without which would render our existence unrecognizable from today's. Our lives, from the dawn of time, have been created and dominated by a set of power laws, of which thermodynamics, much like oil, and its fraction derivatives, have influence and sway over our most basic modern needs. Over $3 trillion of commodities trading is done every year, of materials which our modern society simply could not function without. The most prevalent of which is oil, and its fraction of derivatives, which equally and completely dominates one to many thousand aspects of our modern life, well-being, safety, and existence. A factor which is perpetuated and which thankfully drives us into the arms of need, the mother of invention, within ourselves and even wider still in commercial and academic institutes. We have thus bonded our lives to the acquisition of these commodities and invention based on needing to avert now numerous climate and looming ecological disasters if ecologically sustainable material technology solutions are not found. These common factors has stimulated us to innovate new, positive ecologically innovation-driven, commercial and sustainability value solutions. Through furthering our understanding of their material dynamics and ultimate sustainable value, now and for our futures, which includes innovating solutions which evolves up the commercial value chain, the residues of globalization, namely classified waste sulfur, which has also proven to have negatively contributed to our experience now of accelerated climate change. Obscurea is a mineral formulation which was inspired into innovation to develop a sustainable and ecologically rooted thermostructurally absorbing lightweight, extreme temperature, physical and chemical phase change, industrial material technology. Obscurea was designed and specifically formulated to integrate and positively thermodynamically enable the high temperature stability of current to future engineered, commercially and ecologically sustainable thermostructural infrastructure and architecture solutions. Indeed, just as oil has shaped the way we live, Obscurea has applied thermodynamic power laws relative to the conservation of energy and the fraction material components of any given material system, decoding positively the relationship to a material system's thermodynamically influenced true effects brought about by the effect upon a given external and internal thermally influenced breaking of a material system's bonded states and subsequent thermal phase changes. Obscurea has developed a thermodynamic material system formula from natural, sustainably abundant, and widely available raw materials, which has been shown to highly absorb and internally encapsulate external thermal influences and by so doing, enhance and enable industrial thermal management product processing options in numerous end products, commercial host material systems. Obscurea has been certified proven, according to ISO Thermal Performance Assessment Standards, to positively influence and encapsulate the emitted exothermal energy of a given commercially known material system, initiated by and from an external heat source event, into a thermochemically secure, thermodynamically influenced material phase changes within a closed Obscurea-enabled material system, relative to the end product's designed material composite and system function, of which Obscurea-based material technology has been proven and certified, according to the highest ISO standards, to enable positive structural thermal phase change dynamics. Obscurea encapsulates within the lowest temperature material element right through to the surface of a material system, therefore altering the thermostructural dependence of each other element within a given material commodity to maintain, enhance, and extend the material system's end function. In every commercial end product there are limitations, which can and are driven and instigated by thermodynamic influences. This is most clearly demonstrated in the distillation process, where many other material products can and are extracted based on their thermodynamic influence and ultimate valued extractability. Which brings us to the subject of the value and known commercially practical influences of the base negative value fractions of oil, bitumen, and ultimately sulfur. It is presumed common knowledge that petroleum industries produce more sulfur byproducts than the market can industrially absorb positively. Consequently, large stocks of yellow sulfur have piled up near remote operations, or managed otherwise in a heated molten form in tankers on the open seas. The fallout of which being growing amounts of toxic hydrogen sulfide, H2S, being released into the atmosphere, and or being disposed managed in subsurface waste dumps. Unless sulfur demand drastically increases or thorough disposal practices are developed, byproduct sulfur will persist as a chemical waste problem on the scale in excess of 100 tons per year. Bitumen is quite possibly an unsung hero of the lower value fractions of oil in our modern world. However, much bitumen has and remains an ironically invaluable fractioned resource of oil. It leaves in its wake cruder fractions outside that which has been deemed most industrially and functionally valuable grades of bitumen. Sulfur, chemical element with the symbol S and atomic number 16. A nonmetal, sulfur is the 10th most abundant element in the universe, according to the Jefferson National Linear Accelerator Laboratory. Today, its most common use is in the manufacture of sulfuric acid, which in turn goes into fertilizers, batteries, and cleaners. It's also used to refine oil and in processing ores. Pure sulfur has no smell. The rotten egg smell is associated with the breakdown elements of its fractional compounds. Today, almost all elemental sulfur is produced as a byproduct of removing sulfur-containing contaminants from natural gas and petroleum. The greatest commercial use of the element is in the production of sulfuric acid for sulfate and phosphate fertilizers, which also includes other byproduct chemicals in the processes. The element sulfur is used in matches, insecticides, and fungicides. Many sulfur compounds are odoriferous, and the smells of odorized natural gas, skunk scent, grapefruit, and garlic are due to organosulfur compounds within sulfur. Hydrogen sulfide gives the characteristic odor to rotting eggs, to name one degrading waste biological process. Sulfur is an essential element for all life, however commonly almost always, in the form of organosulfur compounds, or metal sulfides. Its most natural and industrially valuable ability, for further commercial innovation to be extracted, is sulfur's binding properties as a natural adhesive polymer. Sulfur becomes a processable polymer, with a long polymer chain DNA-like scaffold of linked molecules, seen in end products and derived from and enabled by sulfur. In known familiar industrial commodities plastics, sulfur, automatically when heated above 320 Fahrenheit, or 160 degrees centigrade, becomes a liquid, and has a low resistance to flowing, much like engine oil. This reaction and its industrial innovation possibilities has been known for more than a century. It is these fundamentals, coupled to the certified positive thermodynamic, structural integrate properties enhanced by the introduction of Obscurea into a given sulfur-based material system, which has provided sulfur, combined with Obscurea, an ecologically sustainable, environmentally responsible and accountable, new and far-reaching future value-added, engineered thermochemical innovation possibilities. New thermodynamically enabled enhancement to material systems have and are continuing to emerge as new enabled sulfur Obscurea material value-added commodities current and future waste fractions of oil's byproduct sulfur. Through continued welcome collaboration with oil-producing nations and the key refineries network, to enable a storage, and ecologically negative fallout of the pivotal role which oil has played to drive and deliver the means of industrial globalization, with opportunities to fraction further and evolve new upcycled high thermal and structural bonding performance material product solutions. Right at the heart of the oil refining process and sulfur waste storage management locations. Working alongside other sulfur innovators, commercial and academic. To further with Obscurea, decode the mysteries of the power-law relationships, which enable a material system to function consistently at all extremes of temperature and everything else in between, into value-added ecologically and commercially sustainable end product solutions, based on sulfur waste from oil refining, from which Obscurea projects many mutually beneficial collaborations, which can further evolve ecologically, technically, and commercially, from a human hardwiring socially responsible self-preservation, based on need, to enhance our modern-day and future engineered road, rail, and architectural infrastructures, with competent certified and process-regulated Obscurea material technology-based thermostructural dynamics, and sulfur commercial upcycling. Obscurea future engineered inceptions with refinery waste fraction sulfur, relies on mutually embraced instigation and the conception, within the collective womb, embryonic desire, and encapsulation, to go beyond our inner mother of invention need, to sustainable ecologically evolved, innovation futures now. What is clear, is that, there must be, a fundamental understanding, of the basic, thermodynamic phenomena of Obscurea, relative, to the basic laws of thermodynamics associated, to the beneficial thermal management influences, which Obscurea does, and can have, on current industrial, infrastructure, and architectural, material system solutions. This clearly, is to be an enabling factor, in implementing, future engineered, evolved enhancements, of numerous commercial industrializations, of current and yet to be discovered, implementations of Obscurea material technology, to positively ecologically and commercially meet our responsibility to our environment now, and in our children's futures. On behalf of FWGK and Obscurea, thank you for taking the time to watch and listen.